Hi guys, it's Mrs. Millison. Okay, let's learn about variables. This is a math class, so you know you're going to have variables. All right, let's go ahead and create our class file, and we're just going to call it Unit 1 Variables. Whoop. Okay, open up my brackets, close my brackets, and then we'll do our main method. Oops. Oh my goodness. Open up the bracket for my main method and close the bracket for my main method. Okay, there are two types of variables. I'm going to put some comments in here for notes. So there's two types of variables. Oh my goodness. Primitive and object or reference is the other ones. Okay, a primitive variable, we'll do the primitives first. Well, first, before I say that, all variables have to be declared and initialized. Okay, so declaring is creating them, talking about what type they are, giving them a name, and then initializing is giving them an initial value. Okay, so for that, now let's go ahead and do primitives. Okay, primitive variables are just your basic variables. Okay, and how the computer holds primitive variables is it actually holds the value of the variable in memory. Okay, and we'll talk about how that's different from object and reference variables. Okay, to create a variable, no matter what it is, we're going to follow the same pattern. We're going to identify the type of variable, we're going to give it a very meaningful name, and then we're going to set it equal to its initial value. Okay, and we're always going to end our line of code with a semicolon. Okay, so the three primitive variables that we are concerned with are int, okay, I'll make a little space here, which are integers, 1, 2, 3, 4, 5, 0, -7, that type of thing. We have double, which would be decimals. Oops. Decimals. And then we have boolean. Definitely spelled that wrong. Which is simply going to be true or false. It can have no other value except true or false. Oops, I need a double slash for my comment. Okay, so for these are all the different types. So we've got int, double, and boolean. Those are the types. You always start when you create a variable. You always identify the type. Okay, and you'll see that throughout this whole course. All right, so let's think of what type of thing would we use an integer for? I don't know. How about somebody's age? So I'm going to call this age. So this is now my variable name, age. Now names, let's put a little note here. You make up the names, okay? Int is a programming word, but age, I made that up. I could make that XYZ, okay? It's math, it's variables. It could be X, Y, or Z or anything, but you make up the name, okay? Names should be meaningful. Okay, so if I am going to talk about age, I'm not going to name the variable A, because later down the line I'm going to be, what did A actually stand for? Oh, it stood for age. Okay, so use meaningful names. Okay, and you'll notice that I wrote age as lowercase. They're always going to start lowercase. They're called something, they're in something called camel case, okay, where they start as lowercase, but then if there's any words in them, because if we have multiple words to describe it, like maybe this is, I don't know, age of something or other. We'll do camel case. Any other word has to have a capital, okay? All right, so we'll do initial age. Let's see, what would we do for maybe something for a decimal? How about hourly rate? Okay, so there's hourly, and then rate is going to be capitalized. And then a Boolean is, again, only going to have a value true or false. So let's say, is sunny? Okay, so we want to know if it's sunny outside. So now I've got my three types, and I've got three different names. And again, I make up the names, but make sure they're meaningful and make sure they follow the camel case. Okay, now let's just set their initial values. Let me give them all equal signs. And let's say, which do we make the age? We'll start with 10 years old. How's that? Okay, hourly rate, I don't know, what did I have? $8.75 I put in my notes. Okay, move my cursor. And then is sunny? I'm looking outside. I'm going to say true. Okay, so now I've created 3 variables, an int, a double, and a boolean. And I made up the names, and then I initialized each one with a value. Okay, now I can take these variables and I'm going to print them. Okay, because right now, oh, you know what? Let's compile. See if I've made any errors. Hopefully I have not. I don't have any errors, but I do have some warnings. And the only thing the warnings are saying is that my variables are not being used. The variable age is not being used. The variable hourly rate is not being used. And the variable sunny is not being used. Well, let's use them. Okay, so I'm going to do a printout statement. Now I can just print, if I just print age, okay, plus hourly rate plus is sunny. Let's see what happens. Oh, whoops, I wrote in sunny, not is sunny. Okay, it thinks I'm trying to add the values, so that's not going to do it. Okay, let me do one at a time. You can't add numbers to the word true. Okay, that's not going to work. All right, let's just do this one then first. Okay, again, I didn't get any errors. I'm still getting some warnings that hourly rate and sunny is not being used. Actually, let's print them all out so we can get rid of that warning. Hourly rate. Oops. Okay, oops. So now, here we go. Now we're not getting any warnings that our variables aren't being used. So now when I print them, I'm printing 10, 8.75, and true. Well, these are the values that these variables have. Age is 10. Hourly rate is 8.7, and is sunny is true. Okay, so I'm not going to print those words. I'm going to print the value of the variable. Now, let's say I want this to say age is 10. Hourly rate is 875. Well, I've got to add a string literal. So remember, age is my variable, so I'm going to put in quotes, age is space, and then my plus. So now this will print out age is 10. Okay, and we'll add a string literal for this one. I'm going to put a space here. Oops. And then I'm going to say, is it, no, I was going to put sunny. Oops, no, good heavens, with a question mark. How's that? So it'll say true or false. And again, why am I putting that space right here before the quote? Because I don't want the number 10 to be right next to the S in is. Okay, so I've got to put that space in there for myself. So now when I run, okay, so age is this text, and then 10 is the value of the variable. Okay, hourly rate is that text, and then 875 is the value of that variable. Okay. Now, what if, let me show you another little shortcut. You don't have to declare and initialize at the same time. I can declare multiple variables of the same type. So I'm going to do, I want to do length and width, okay? So I can say double, so I'm declaring the type, and I'm going to do length and width. I'm going to do length, comma, width, okay? So I have just declared 2 variables, length and width, that are double. So I'm going to be able to put decimals in them, but I haven't initialized them. But you can declare multiple variables of the same type on one line, okay? So I'm probably going to get the message that length and width are not being used. Yeah, I know that. Let's give them a value before we print them, okay? So now I can initialize them. Let's see, length is 7.2, and width is, not is, I don't know, 5.1. I don't know, okay? So now I can print. Now they actually have a value. Let's see, length is length, and width is width. Oh, I could spell that right. And that should do it. So I should print out length is 7.2 and width is 5.1. Let's see. And indeed it did. And I got all my spacing right. I got a space there before the word length. I've got a space in front of the word and so that and doesn't come right after the number 2. Trust me, when you start printing stuff and you forget the spaces, you'll quickly see it when you print it out. Okay. Okay. It's kind of, and you don't have to do this either way. I just want to show you that you can declare and initialize on one line, or you can do them on multiple lines. Because there'll be times when we declare a variable and we don't initialize it till much later. Okay. All right, the only other thing I wanted to show you before we talk about object and reference strings is changing the value. Okay, let's say I'll keep this since we just did it. I'm going to change length. I want length to now be 10.8. Okay, I'm going to cheat a little bit and copy and paste this. I'm going to have to retype it. So now if I come down here, I'm going to get rid of the width part just to see the difference. So now when I run this, when this prints, length is going to be 7.2, but when it comes down to this line, length is going to be 10.8. Okay, because remember, programming, it runs from line 1 and it just keeps going down. Okay, it doesn't backtrack. Okay, and once you change something, it's changed. Okay. Let's say I wanted to create another variable for length, width, and height. Okay. But I always want height to be 9.5. I don't ever want it to change. Okay. What I can do is I can put the word final in front. Okay. See how final kind of turned blue? This means I can never change the height. Okay. So if I come down here, oops. Or height is see all my, oh, what did I forget? Let's see what my error says. Syntax error, insert a semicolon. Oh yeah. I tell you, you gotta love the errors. They tell you exactly what to do. Sometimes they're a little hard to read. Okay, so height is 9.5. Agreed. Okay, now if I come down here and try to change height to 1.1, okay, I should get an error. Yep, the final local variable height cannot be assigned. It must be blank and not use a compound assignment. Okay, I can't change it. I've set height as final, so it can never change from 9.5. Okay, so I cannot do this. It won't let me do it. Okay, so what are some examples of when we would want a variable never to be able to be changed? Maybe if we were using pi, because we always want pi to be 3.14. Maybe if we were doing something and we were trying to calculate something based on a specific hourly rate and we'd want that to be modified, we could make hourly rate final. Okay, so you'll see as you go through, there'll be times when you want a variable to always stay what it is. You don't want anybody to be able to change it. Okay. All right, so those are our basic primitive variables, int, double, and boolean. Okay, so we've done a little bit of printing with some literal strings, and this is called concatenation, where we're just adding pieces of text together. Showed you how to declare and initialize separately. You can declare multiple variables of the same type together, and a final or permanent variable value. Okay, let's do object or reference variables. Okay, now what the difference is, a primitive variable like this number, this value 10, the computer is actually keeping the value 10 in the space that's assigned to age. Okay, but what's going to happen with an object or a reference variable, the computer is actually going to not necessarily keep the value housed to the variable name. It's going to keep the value. It's not necessarily the value. It's a reference. It's going to always point to the object, okay, or the reference. So you'll see later on where we can point multiple variables to the same object. Okay, and we'll talk about that later. Just a quick little overview. Okay. Okay. The main object reference type that we're going to use is called a string. okay? And really what a string is, it's an object made of multiple characters. So there is another primitive type. There's a couple other primitive types called char, C-H-A-R, which is short for character, which is like a single letter, okay? So a string is actually a collection of multiple chars or multiple characters. We don't need to worry about chars though. We don't do any of those, okay? But we follow the same pattern of type name equals value, okay? We follow that same pattern. Where am I? Up here, okay? But this time it's not necessarily just it's not a primitive type, it's an object type. So no big deal. Okay, so we're going to do string, and you'll notice that objects are now, their types are capitalized, and we will see that over and over again. Okay, so int, double, and boolean are primitives, so they're lowercase types. Okay, objects are uppercase. So string, what should we talk? Oh, let's do our school. Okay, equals, and of course we're going to say, now it is a string, so it is going to be a collection of letters, so we need to put it in quotes, JHS. Okay, so now I just created a variable school that holds the string, which is a collection of characters, JHS. So now if I go to print out, our school is school. So now when I print this, I should get our school is JHS. There it is. Our school is JHS, okay, because it's finding that variable. And I can change this. If I want to come down here and say school equals, let's spell it out. Maybe I don't want it abbreviated. Okay. And then I am going to copy my print statement down because I don't feel like retyping. Trust me, you'll copy and paste a lot. Okay, so the first time it ran, it said our school is JHS, which is right here because school at this point equaled JHS. Then we changed school. Now school equals Jefferson High School. Okay, now this was a quick way to create an object or a reference variable. The formal way, okay, this is the formal creating an object. I want to go over this because you're going to see this. Again, I would have to do type name, and I would do equals new type, and then put the value in parentheses. Okay, so just watch. So I would do string. Let's do county this time. Equals new string, and then my value is going to be Jefferson because we're in Jefferson County. Okay, so this is another pattern. Okay, this is the pattern how we create an object. It looks very similar to the pattern on how we create variables, but I just want to introduce it to you because you're going to see this when we create other objects. Okay, let's just do a quick little print statement. I'm going to copy this because again, don't want to retype. That is in county. Okay, so what am I saying here? Our school is Jefferson High School. That is in Jefferson County. Okay. Finish compiling. And there we go. Our school is Jefferson High School. That is in Jefferson County. Okay. Okay, so we have learned about the main variables we're going to use. We're not going to use any other primitive variables except int, double, and boolean. Okay. We are going to use lots of different types of objects besides strings, and we'll use strings a lot. So when I declare a string, I do it like that. Okay, I don't do this long formal creation type. I mean, why? This is a shortcut. Okay, but again, I just wanted you familiar with this pattern for creating objects because we're going to create a lot more objects in the future. Okay, great. I hope you enjoyed this. See you next time.